Hello, in this video, I will explain to you on how to find out the Thevenin equivalent. So that will be our goal, which is to find the Thevenin equivalent to the left of terminal AB. So we need to find out two things, which is the first one to find out the Thevenin voltage, VTH, and the second one will be the Thevenin resistance. We will find out later, but we need to find out VTH first. Okay. And I think we need to do circuit analysis on this circuit here. Okay, I will do nodal analysis and I will set this node here as our ground or our reference node. And reference node meaning that the voltage here will be equal to 0. So we know exactly the voltage in this B here is equal to 0. But then right off the bat, we know that this node here is 2 VO from the ground. VO. But what is VO? VO is the difference between this node and this node here. So we need to name this node. Okay, maybe this is terminal A. So I will name this node here as VA, the voltage at terminal A. Okay, we need one more node here. Remember that this is a big node here because it is directly connected. So we will have this name as C, right? A, B, C. Okay, the voltage here will be VC. But then we know that VO is equal to VA minus VC because voltage is the difference between two terminals, right? So we will have VA minus VC. So I have VA minus VC. That is VO. Okay, now let's see what else that we can get. This is dependent on IO, but what is IO? IO is the current that passed through this 20 ohm resistor. So we need to find out what is IO. IO is the voltage divided by the resistance. The voltage comes from, the current comes from VC and it goes to the reference node. So I have VC where the current comes from, and then minus 0 where the current goes to. And we need to divide it by the resistance between them, which is 20. Or in short, IO is equal to VC divided by 20. Good. Now let's assume the direction of the current because we are doing nodal analysis. So this will goes down, this also goes down, and this one goes down. And this goes to the right because that is a current source, and this one will goes up here. Good. Now let's do KCL at node VA first. Okay, let's do KCL at node VA. And what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, there is only two currents involved in VA, this one and that one here. And this is the current that goes in, and that will be 0.1 VA. Okay, 0.1 IO. And then the current that goes out here is this one here, and the current comes from VA. Then the current goes to VC. So I have VC here divided by the resistance between them. I will have 10. Okay, we can cross multiply. So I will have IO here is equal to VA minus VC. Good. And remember that IO is VC over 20. So we'll have VC over 20. And that will equal to VA minus VC. Okay, we can multiply both sides by 20. So we'll have VC is equal to 20 VA minus 20 VC. Or we can simplify things. So we'll have 20 VA minus 21 VC here. And all of that will equal to 0. Let's set this as equation number 1. Good. Okay, now maybe let's clean up things a bit and save this equation here that we got. Okay, now let's do another KCL, but this time at node VC. Okay, KCL at node VC. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. Now, the only current that goes in is this one, and that current will be VA, where the current comes from, right? And then VC, where the current goes to, divided by the resistance between them, which is 10. Good. And all three currents are going out. We will have this one here first from VC, right? It's going out. And that current is 0.1 IO. So we'll have 0.1 IO. And then what else? I will have this current here, and that current will be plus. We will have VC, where the current comes from, and then minus 2VO, where the current goes to, divided by the resistance between them. I will have 40. And then for the last current that goes out, I will have VC minus 0, right? So we'll have VC minus 0 divided by the resistance between them, and I will have 20 here. Good. Okay, let's multiply both sides here by what? By 40, I think. Yeah, I think I will have 40 here. And 10 and 40 will cancel into 4. So I'll have 4 PA minus 4 VC. And then 0.1 multiplied by 4, that will be 4, right? So we will have 4 IO. But then IO is VC over 20. Let's plug that in. So we'll have VC over 20. And then VC minus 2VO, so we'll have 40 cancel each other, so I can just copy that. So we'll have VC minus 2VO. And then 20 and 40 will cancel each other, so I'll have plus 2VC. Good. What can we do from here? Okay, maybe let's multiply both sides here by 20. I want to cancel out that 20 here. So we will multiply both sides by 20 here. And I will have ATVA minus ATVC. And then that will equal to 20 and 20 will cancel into cancel each other, right, into 1. So I will have 4 VC. Good. And then I will have plus 20 VC. And then I will have minus 40 VO. Minus 40 VO. But then VO is VA minus VC. VA minus VC. Good. And then plus 2 VC, so I will have plus 40 VC. Okay, maybe let's distribute this 40, so I will have minus 40 VA, minus 40 VA plus 40 VC, right? Minus 40 VA, then plus 40 VC. Good. Now let's do what can we do from here. Okay, VA, I think we can get it from here. So I'll have 120 VA. Then I will have minus 80 VC. And I want to calculate all that VC here. So 40 plus 40 is 80. 80 plus 20 is 100. 100 plus 4 is 104. So we'll have 104 VC. Move it to the left hand side, and I will have 120 VA, and then minus 184 VC. And all of that will equal to 0. And this is equation number 2. Okay, we have equation number 1 and equation number 2 here. Okay, let's solve that using calculator, right? That is the fastest way. Okay, let's see here. Let's set this up as equation solver. Number 5, two variables is number 1. And I will have the first equation, 20 minus 21, and then 0. And here I will have 120 minus 184, and finally 0. Okay, my feeling we get VA and VC is equal to 0. Good? Yeah, VA is 0. VA is 0 volt. And what is VC? VC is also 0 volt, I'm sure. Yeah, that is it. So I'll have VA and VC is equal to 0 volt. But then we need to find out the VTH, right? What is VTH? VTH is the open circuit voltage at this terminal here. So we can get it because the positive one is connected to VA here, and then the negative one is connected to the reference node here. So we can calculate VTH, right? VTH is equal to VA minus VB, but our VB is our reference ground, so we'll have VA minus 0, and that will equal to VA. But then VA is 0 volt, so we get our VTH here is equal to 0 volt. Okay, let's save this because this is one of the most important values in this problem. Okay, that is VTH. And the second step is to find out RTH. Okay, we need to clean up our slide. Okay, the second step that we need to do is to find out the RTH, the Thevenin resistance. Okay, because we don't have independent sources, we don't need to turn off anything. But because of these dependent sources, we need to put a dummy source at AB here. Okay, so we will have plus and minus here. And we will have this one here as 1 volt here. And so we will need to find out what is this current here. Let's name this as I. Okay, so what is RTH? RTH is 1 volt divided by I, right? This I here. Okay, and let's do nodal analysis, right? So let's set this here as our ground. So we will have the voltage here will be 0. Good. And now what is this voltage here? Because we put this 1 volt voltage source, the voltage here will be 1. So our PA here is 1 volt. Okay, good. But then we have one unknown node, right? And that node here is this node here. Okay, and that node will be our PC here, PC. And let's see here, we can get this node here as 2VO because that is 2VO from the ground. And then what else? I think we need to assume the direction of the current. This one, and that one here. Okay, that goes down. Okay, maybe put that on the clearer side like that. But then we can get PO here, right? PO is the difference between this positive terminal, which is 1, and then minus the negative terminal, we connect it to PC, 1 minus VC. Good. And then what else can we get from here? I think we can get IO, right? Because IO is PC minus 0 divided by 20, the resistance between them. VC is where the current comes from, 0 is where the current goes to, 20 is the resistance between them. So IO is VC over 20. Okay, now what we need to do is to do KCL at VC here, right? And I think I need one more current here. So this will goes up and eventually it follows this current source, right? So we will need to do KCL at VC. Why? Because we only need to know at VC, right? We know VA already. So KCL at VC. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. the only current that goes into VC is this one, and that current is 1. 1 is where the current comes from, which is VA. VA is 1 volt, and the current goes to VC. Okay, divided by 10. Okay, I will have 10 here, and that will equal to IO here, 0.1 IO, 0.1 IO. But then what is IO? VC over 20. So we'll have VC over 20. Good. Now what else that we can get from here? Okay, I will get this current here, and so we will have VC minus 2VO, yeah, divided by the resistance between them, which is 40. And here I will have this current that goes out, and that will be VC minus 0, that will be VC, divided by the resistance between them, which is 20. Okay, I think we can multiply things here by 40. Right, 40. So 10 and 40 will cancel into 4. So we will have 4 minus 4 VC. And that will equal to 20 and 40 will cancel into 2. So I will have 0.2 VC, right? 0.2 VC. And here I will have VC minus 2VO because 40 and 40 will cancel each other. So I'll have VC minus 2VO. But what is VO? VO is 1 minus VC. 1 minus VC. Good. And then here we will have 20 and 40 will cancel into 2. So I'll have plus 2 VC. Good, and I think we can solve for VC from here, right? Or maybe I want to multiply this by 10 to get rid of that 0.2. So we will have 40 minus 40 VC. And this one will be 2 VC. And then this one will be plus 10 VC. Okay, and then I will have minus 20 here. But we can multiply things, so we will have minus 20 plus 20 VC. And then I will have plus 20 VC. Okay, let's move this minus 20 to the left-hand side. So I'll have 60 minus 40 VC. And then I will have this one here, 2 plus 10, that will be 12. 12 plus 40, that will be 52. Yeah, I will have 52 VC. Okay, and I will have 60, that will equal to 92 VC. So we can isolate for VC here. We can get VC here is equal to, I think I just leave it into 60 divided by 92. Good. But we need to calculate this I here, right? And what is I? Okay, maybe let's clean this up because we already know the value of VC. Okay, now our task is to find out I to get RTH, right? So what is I? We can do KCL at VA, right? KCL at VA. What is KCL at VA? The sum of the current that goes in will equal to the sum of the current that goes out. Good. Now, the current that goes in is this one. I will have I. Okay, and then this also goes in. So I will have plus 0.1 IO. 0.1 IO. But then IO is, remember, IO is VC over 10. I mean VC over 20, right? So IO is VC over 20. Good. And then that will equal to this current here that goes out. So I will have VA and then minus VC divided by the resistance between them, which is 10. Good, and we can isolate I from here. So you have VA minus VC divided by 10 minus 0.1, and then we will have VC over 20. Good. Now we know all the things, right? We know VA, we know VC, and so on the right hand side it is just a number. So we have I is equal to 1, and then minus VC. VC is 60 over 92 divided by 10, and then on this term here I will have 0.1 multiplied by 60 over 92 divided by 20. Okay, all we need to do is to plug this into calculator, right? So we will have this. Okay, let's prepare that. We will have 1 minus, okay, that will be 60 divided by 92 divided by 10. Okay, that is the first term. And then the second term here, I will have 0.1 multiplied by, we will have 60 divided by 92 divided by 20. Okay, and I think we can get this. So our I is 29 over 920. So I'll have I is 29 over 920 ampere. But then we can just flip it to get RTH, right? Because it is 1 over I. So we'll have 920 divided by 29. Good. Now let's do that. So I'll have 920 divided by 29. And that will be 31.724. So our RTH is 31.724. And the unit will be ohm. So that is our RTH. RTH is equal to 31.724 ohm. Okay, and that is VTH and RTH. Let's do the final step of this problem. So the last thing that we need to do is to draw the Thevenin equivalent. So we will have a voltage source here, 0 volt, and then we will have 31.724. Okay, and that is terminal A, and this one will be terminal B. And that is all for this problem. Thank you for watching. See you in the next video. Bye bye.